Yeah. Okay, so last time we had some fun making a background as a fragment shader that will be a slight, Easter egg or a troll, however you want to say it. The background will slowly change from like polka dots to this diamond pattern over time. Currently though, what is the game like? Yeah, currently the background is this boring gray, and so today I simply want to get this pattern as a fragment shader, of course, into here. So yeah, hopefully this is straightforward, but we'll see. OpenGL has a lot of nasty surprises. I think the first thing is I'm pretty sure the one we want to use is this like polka.troll.glsl. So we'll need to get this into the game. Yeah, so when we made this, we just had a single function that called two fixed shaders. But now we have two. We have two GLSL files. So we'll want to kind of like refactor this as a just separate function. Okay, so let's see what are we doing? Yeah, we're creating. We're just like storing the ASCII of these things, kind of pushing them to the shader, trying to compile them, checking that they did. If they didn't, print out an error log saying why, try and link them. If not, print out a log saying why, and then delete these. Okay, so we should be able to really factor these out. Okay, so let's like pass these in as functions. So we'll have a null terminated string, which will just be the vertex shader. And then likewise, for the fragment shader, we'll pass in another slice with a sentinel that is the null byte. And then we'll want to, instead of just returning nothing or a shader compiler error, we'll want to return a kind of program, or at least it's already been stored on the GPU, so we just need to return this PID. And the PID should just be a CUINT. Okay. Provided we haven't. I feel like we should just use the type alias here with the shader program. Okay, so then we'll need to actually return that, and we'll want to use these arguments. So let's see, this VSS location should just be, well, it should just be the location of the first element in, we'll keep it the same. And actually, let's just call this like vertex source and fragment source, not fragment source. Maybe it is actually better just to leave this as vertex shader source. It's just unambiguous. Then we don't really change anything there, except at the end we want to return. Okay, we'll want to get rid of this global shader. And so here we'll want to just... Okay, do we actually want to make the shader active at this stage? I don't think so. Given we're going to be swapping, we're going to be using, at least at this stage, 2 shaders, and of course we'll be using at least three once we start doing like the texture, start rendering like the texture of whatever image we'll use, like the earth. It's probably good not to do that just here. Okay. Let's also rename our current vertex shaders. So let's just make a different subdirectory called shaders and move that into this, and we should call this one like flat color, or like color geometry. Or like vertex. Like vertex color geometry. It's kind of like this. It's like the simple color shader. Yeah. Guess I won't matter too much. Or like simple. I want to call it just like flat colors. And likewise for the fragment, we'll just call it something similar. Fragment, flat colors. Okay, and then we'll want to move our like polka dot troll shader and just call this like fragment background .glsl. Okay. All right. So now we'll want to get those in here. Where should we put them? I feel like if we're just embedding them, we should be embedding them near the top of the file. So we'll call it shaders. So let's see. We have I think if we just call them the same names, it's the easiest way to remember them. Vertex flat colors is just embed the file that is in shaders, and then vertex flat colors. The fragment. replace vertex with fragment. And then, what's this one? Fragment, fragment, background. Okay. Before we start trying to get the background rendering, let's just get the, since we've modified some stuff, get it working as before. So now this compile shaders needs to be adjusted. So in particular, since we're now returning the program ID, we want to just call this like flat geometry shader. We'll call this compile shaders. Oh, hey, boo, hang on. It may make more sense to actually just have a function called like compile shaders plural, and in that we just like call we just separately like compile each one after the other. Okay. Yeah. So let's change this function to compile shader, and then create another one called compile shaders. This one truly will be the same return type as the old function, namely nothing or an error. And then in this we'll just pass the errors up. We can say trial compile shader. Ooh, I think it would make more sense to be embedding the files in here. But then, like in terms of reading the code, having like the paths of these shaders in here would be better. At the same time, I feel like if anyone looking at the file, you want to just almost immediately know if the file is, how this file is connected to other ones, and just as such, we should actually keep this at the top. But anyway, okay, so here we want to say, yeah, the flat color shader is equal to try to compile the vertex flat colors and then the fragment. Why am I calling this flat color? Let's just remove the plurals from these. I'm doing like fragment again, so many times. Fragment, come on, fragment, flat color. Okay, there we do want to be able to reference this in other places though. So maybe we do actually make this a global. We just let's call global shader before. No. Yeah. Flat color shader. Let's see what We'll remember to do the other shade. Okay, let's try and compile this. Zip build run. Uh-oh. So, it's compiled alright, but at no stage are we using it. We need to actually call call that. So we have use program. And this line we uncommented. This is quite important. So we want to let's jump to our render function. When we're drawing the grid geometry, that's when we're just writing to like the vertex, like the kind of the buffer, the color vertex buffer. I guess before we actually draw this is where we want to use the program. So we want to say use program. What's the name of shader? Flat color shader. Okay. Yeah, let's build this again. Great. Working as before. That is good. Let's save this. Yeah, we have added a lot. Git add shade. Look, I cannot wait until Ghosty gets ported to Windows. PowerShell is so bad. It's so bad. Git add. Maybe just add everything. Refactored. Made it possible to compile more than one shader. Okay. All right. Okay, so now that's working. Let's try. We wanna start compiling our background shader. So when we made this using the code life, let's see, file, open recent, this thing. You're right, we weren't, code life was itself passing in uniform floats for us, passing in uniform radiuses, all of these things. We'll have to do this ourselves when we're embedding it in our own standalone program. For the moment, we can make both of these a bit easier by just declaring the whatever here is a uniform to be constants, getting the stuff on the screen, getting the stuff as the background, and then updating these a bit later. So okay, we're also going to have to I forget if like OpenGL allows you just to use like a fragment shader. I suspect it doesn't. So we might have to just use like a dummy vertex shader that just pushes some kind of data to the fragment shader, which it then completely ignores and just does everything pixel by pixel. Okay, so if we go into the shaders and in particular this background, let's convert all of let's move like the uniforms together to begin with. And then make all of these constants instead. So yeah, so we want to say let's make the time equal to like 0. Replace these with uniforms once the frag shader is rendering. So we may as well make the radius here. I guess the radius here should be fixed anyway. We weren't really going to adjust that. Although we may want to, like depending on like the end of the game, we might want to do something really like fancy and flashy with the background. So we like, for instance, we could like shrink everything at the end of the game. So we may actually want to keep that a uniform. And then I feel like for the reps though, we do want to keep this constant. Yeah. Are there any other uniforms? No. This LP old can go. Okay. So now we want to make a vertex shader for this. Vertex background dot GLSL. And I think for this we can just keep it really simple. So like for this flat color one, we could probably just copy it and modify it a bit. Yeah, I really want to just like pass in like the kind of the simplest stuff. So let's see. So to draw this background, what are we going to have to do? We're going to have to just draw a rectangle. So we can just draw that as 2 triangles. To draw those triangles, we'll need the positions, but nothing else. So get rid of the color here. In terms of the output, why were we using our color here to begin with? Yeah, we won't need that. We'll just want the GL position, and I guess we can just use everything else to be the same. Let's just note that this is a copy passed from vertex flat color.glsl. Okay. Okay. So then in our background one, yeah, we're not. Hopefully this like frag color here won't whinge. We may need to do something about that. But okay, but let's give this a go. So. Okay, so now we'll want to use the polka dot shader to draw the background. Yeah, that's what we're doing. I guess we do need to add in a header for this project. Fragment background. Where did we use this? Okay. So here, yeah, we're compiling the flat color shader, and then we want to do the background shader as well. If we store this as a global, the compiler won't whinge that we're not using it. Let's place flat, color, color with background. Okay. Okay, we're now gonna have to, okay, let's just try and compile this. And see if this, this issue of, oh hey, both of them did compile. All right, great. That is good. And then we did link all of them, yeah. Okay, I'm kind of not liking in this error message that it's vague as to what shader actually compiled. If we're already like pushing something to the screen, it should at least say what it is. Debug vertex shader compilation success. Is there like an easy way to just like describe what this is? We could just pass it in as a string. Oh, that's kind of nasty. Oh, maybe we can use some like Zig intrinsics for this. This would be some advanced Zig programming, but we could. I think we could look at. Actually, doing this with a struct might be the easiest. For each like shader, we just make a struct where there's 3 fields, the third of which is just like the name, and then you just have like the vertex shader, the fragment shader, and then what you want to like name it. But the only time the name would be coming up is in this kind of debug message. So certainly, like in Zig, very well known throughout the compiler. If you have some struct, you can just look up like the names of fields and. But now I'm wondering, is there some way to tell the compiler, kind of like in some way remember the name of this thing? Probably not. Okay. Let's just print out the PID in the very least. So we have this, yeah, vertex SID and F SID. Vertex shader, blah, compilation success. And then by here we'll just put out the SID. And here we'll say fragment shader thing compilation. And then here in terms of the linkage, fragment shader linkage, we'll have the, what is it called, the PID. At least in this case now, we'll get, there'll be some more numbers. Okay. Actually, the 3 should have come before the linkage. Okay. I'm still trying to think like if this will like why this would be useful if we end up with something failing a bit later. Maybe we'll just keep track of it. Like this program's small enough that this doesn't actually matter, but it's something to ponder. Okay. So now that all of them are compiling, yeah, we'll want to. We need to come up with a different vertex layout inside the data we're pushing to the GPU, even though all we're pushing is just like a rectangle, so something we will specify manually. I guess setup array buffers is what we want to modify next. Okay. So, first of all, did we yeah, we should save these small additions we made. Made uniforms in background shader constant made background shader compile. So yeah, so what are we going to do with this? So this is where I need to like debug my knowledge of, or at least refresh my knowledge of OpenGL. Like, can we assign when we have this like global VBO, do we need to assign another one, or can we just assign like different vertex attrib pointers? I feel like we'll have to create a different one. Do we have the OpenGL book here? No. I think it would be good to download this. Where's the PDF? Click to download. Great. This is what every website should be like. You just control F PDF and immediately download it. Book PDF. That's a really terrible name. OpenGL book. How is the download speed that slow anyway? Oh my goodness. Yeah, so do we need to have multiple VBOs in one VAO, or do we just create separate ones? Okay, if I use different VAOs it works fine, but with only one I don't get it working. Okay, that tells us we're just going to have multiple VAOs. Yeah, let's avoid whatever pitfall this is in. Yeah, this seems to be like a common issue people are running with. If each object has its own set of buffers, then it also needs its own VAO. Okay. And we need a separate draw call. Yeah, obviously it needs a separate draw call. Okay, so let's do that. So no more global VAO. Instead, we'll want the flat color VAO. And then the same thing but with VBO. And then we'll want our background, the same thing but now with background. Okay, so now when we set up the setup array buffers, we'll want to use this flat color and background VAO. Is it worthwhile like factoring this stuff out? I don't think so, since it's like doing that would be really complicated anyway. Let's just do them all separately. These are all being held in global states anyway. So for any of these like global underscore, we want to replace them with flat color. Oops. Oh, it's just global replace with flat color. Yeah, okay. Setup. And then we'll want to do the same with the background. Maybe it makes most sense to let's just copy everything here. And then adjust things as necessary. So this color vertex buffer, technically this is constant, but currently we are we're like resizing it as necessary. This time we'll want to, since we're just drawing like a single rectangle for the background, just specify the data kind of directly. Well, if this is taking up the entire background, we can just make it, because we know all of the coordinates immediately. It's just like -1 to 1, etc. So maybe we can just specify that in the setup buffer. Okay, yeah, let's do it before the GL calls. Oh, the constant might. This is okay. We can kind of trick the Z compiler by not modder. We'll continue with this. So for the background buffer, we want this to be. So we're going to have to draw 6 vertices, and let's just do the calculation. 2 times 6, or rather like 6 times. 6 times 2 F32. So we just want this to go from, select -1, -1 to 1, and then 1. Okay, align it wheelie, zig. I mean Emacs. -1, -1. Now we're doing like the bottom right. 1, -1, 1, 1. Okay. So now we just want to pass let's call this background vertex buffer. I feel like we should make this constant. Maybe, like, we're not adjusting it, but we'll keep it. Background vertex buffer. Okay, so now in terms of the vertex of trivs, we only care about 1. What do the arguments mean again? So, yeah, so at pointer 0, the data, we're sending like two floats of vertex. Something to do with like rows or columns, I think. The stride is now 2 instead of 5, and the offset is 0. Okay. And then we want to enable it. Do we need to like enable something? Do we need to enable the VAO? Or simply yeah, now I'm like, now I'm confused. In either case, we don't really need to do a dynamic draw here since this stuff will be static. And, oh, instead of a null here, maybe this is where we want to just push the data directly. Well, has the GL book downloaded? Oh my goodness. My goodness. Buffer data. This looks slightly different. I don't know, target size, yeah, a point to the data usage. So yeah, here we want to do at background vertex buffer, a pointer to the first byte. Okay. So now when we go to the render, well, maybe we should just run this and see if it's compiling. And it should kind of be the same. Like, we've added more stuff to the GPU. Oh no. Added more stuff to the GPU, but we're not calling it. At least I thought we weren't calling it. And yet it's not drawing. We're gonna have to maybe switch the VAO. Yeah, there's like no VAO usage here, so we're gonna have to swap to that. how do we do this? Swap to a different VAO OpenGL. This isn't what I want. Okay, maybe this is what I want. Buffer rebinding versus binding switching. Oh, what's this vertex array attribute binding? I don't think I've seen this before. No one's commented. No. The first one seems to be pretty usual, but I haven't seen the second one anywhere. Okay, so the first one is... What are these second arguments? Like, we want multiple VAOs. Example OpenGL program with multiple VAOs. Okay, so it's called, we call bind vertex array. Would that be enough? Like, will we need to enable this each time, or should it be saved in the state? I feel like it should be saved in the state. Okay, so in rendering, okay, this is just like, yeah, this is in it. Good. When we're rendering, we just say, I guess you can use program later. But, well, who's posting this? Yeah, it's just the program, bind it, and then the draw command. That's all it is. And then you just do that repeatedly. Okay. So in this case, then, so let's say we we're using the flat color shader to begin with. Then we want to say gl.bind vertex array flat color VAO. Then our push the data, and then finally the draw command. Okay, let's see if that gets it working again. No, once again, a blank screen. That sucks. What's this red book? Like the so maybe it's in the initialization setup that we're now kind of failing this. Are we actually calling bind vertex array at any stage? Array like a trib. No, when oh well, we kind of are. Okay, let's, oh no, okay, yeah, let's comment out all of this. See if we can get stuff rendering again. Okay, yeah, it's there. So what about activating that is screwing it up? Okay, so let's say we just like turn these on. Is that itself enough to screw it up? No. Okay. Is simply binding it in here enough to screw it up? Yes, okay. So I guess it must be this bind buffer line that's ruining it. Yeah, okay. This line here is the problem. Or rather, should be handled with cat. So what's the time? 10:30. Okay, so why is binding this one screwing up? Is it because we're failing to bind the VBO when we call it? Oh, the book's now downloaded. Finally. So yeah, where's an example where like multiple things are getting rendered? Assuming that happens at all, actually. Actually, before we should have always had that book, so that's useful. But this looks like this looks like a post we want to read. Yeah, trying to render multiple objects using this. Use different vertex for each object. Yeah, great. Okay. Basically our case. So yeah, okay. You need to bind the correct vertex array object before the call. Yeah. So okay, so then are we like overriding the vertex positions with this? I thought we're like binding the VAO. Yeah, generating it just like we're doing. Then I wonder, is it something where, where's back to the render? Is it something where we should be using the program like after we bind it back? Yeah, that's still fine, and then no, it's not. Yeah, what's happening here? Part of me wonders if I need to like rebind it within this loop somehow. Okay. Website with Cloudflare fail. Yeah, what's going on? So I'm so confused. Why don't we look up GL bind buffer documentation? So yeah, one thing I kind of want to just try. I feel like I should try binding it again in the render. Okay, so now if we, oh, great, yeah, okay. So yeah, so now this, when this was uncommented before, it was failing. But now that we've like asked it again, we've called it again, it's appearing again. Okay. We will remember to, when we switch the VAO, to like rebind all of the buffers again. Okay. Yeah, from like a very long time ago, I think I spent like an even longer amount of time debugging it, and then ended up trying that and it worked. So again, all of this is like temporary in some sense. For the actual game, we won't be using OpenGL, but to get this thing on the web, we use WebGL. So hopefully it's the same pattern in WebGL. Okay, so now we can try binding all of this stuff. Okay, great. Let's save this. Seems to have set up multiple vertex buffers. Okay. So now let's try rendering with the with this background vertex buffer. So ooh, this is like the moment of truth in some sense. Okay, so now we want to do gl.bind vertex array, the background VAO. Then we want to bind the buffer for the background VBO. Then we want to use the program for the background shader. Then we want to just draw the arrays since we already said this is where the data is. Oh, hang on. If we're like scaling everything by, if we're already in the vertex shader, like doing a lot of scaling stuff, then when we divide it by like 1,000, it's going to get massively shrunk. Okay, so I think in fact for the vertices we'll need to adjust them. Yeah, let's see. So when we're writing to this color vertex buffer, how are we doing it again? Yeah, we're just setting like these rectangle positions, and these things themselves are set using pixels, I think. See tar width, yeah. So, where are we? Okay, so I think with these we actually want to change these up. Then we're going to have like 0, 0, 0, 1,000, 1,000, 1,000, 0, 0, 1,000, 0, 1,000, 1,000. Okay. Maybe just draw the background. Draw the grid and tiles. Okay, moment of truth. Let's see if this works. Haha, and it does. Fantastic. Okay. Oh, it feels so good. It feels so good. Sweet. Sweet. No need to use like Unity web plugin or whatever to like to get some. You can just, if you spend the time learning how to program, you can just get whatever you want on a computer without having to use with code alone. No need to use anything else. Okay, great. I kind of want to let's save this. Status. Got background rendering. Okay. So like we've nearly finished adding the background. However, currently there's no uniforms being modified, and which is why like the background here is static. Nothing is currently changing. We want to, but like, let's just we can see how things modify. So if we go into the shaders and we do the fragment background, if we say change like the time, well, if we change the reps from 7 to like 5, for instance, what is this? Yeah, we end up with, you know, the different thing as we totally expect. I kind of like I do like the 7 more though. But why is this like, this ugly, yeah. Keep this at 7. Yeah, let's try and get the time updating with the uniform. Okay, so how are we going to do this? So we'll need to find like the memory, like the position in memory that let's say like the uniform is occupying. Then call this from the program. Oh, I think we just leave it. We can leave it like this. And we should be up. Oh, at what stage should we update this? Oh, do we use the program and then update the uniform, or is it the other way around? It's probably using the I think we need to call the program first. Okay, so we'll call the program update the uniform, update uniforms. So we need to update the time. It's like the functions do this in OpenGL are so nasty. Okay, luckily we have our OpenGL book here. So just look them up. Okay. Where's the function? Oh, this is it here. Okay. Basically. So yeah, GL uniform F, I think, is what we want. GL uniform F. Oh, 1F, okay. Location. See, location is a good name, not edge 0 or edge 1. That was so ridiculous. Okay, so we do, yeah, GL, alright, GL dot uniform 1F, location value. So for the moment, let's set this float to be a constant. What did we call this? Yes, the time initially was 0. If we make this like 1, when we update it, it should look slightly different. Okay, and then call this like theta. Yeah, call it theta to begin with. Time is better, but like maybe just like time uniform time. That doesn't sound right. Time uniform. Or maybe it's time value. Okay, and then how do we get the location? Get uniform location, the program, and then the string. Okay. Time value location is equal to gl dot get uniform location. Here we're using the background shader, and we just want this to be time. Okay. Let's see if this compiles. Okay. Yep. Undeclared identifier location. Can't immediately tell if that's different, but it's rendering, so presumably it is. So let's now actually adjust this with the time value. So we have this function that's like seconds since, where's like the delta? Yeah, timestamp delta to seconds. So here we want to put in the frame timestamp with the like program initialization. Is it not called the program timestamp? Program start timestamp. Okay. Aha, fantastic. And yeah, the background is clearly changing between circles and diamonds. Okay, the Easter egg or the troll is nearly complete. So now we want to, let's just link up these other uniforms while we're at it. So let's see, we'll keep those here, and then in the actual fragment shader, why do we keep that as a separate line? Yeah, we can update the radius too, but the rep should be about 7. Oh, come on. So, like that. Okay, so yeah, so we have that, the time value location, and then we want the radius. These names are not great. Like time shader location is a bit better. And if we have radius shader location, radius, and what did we set? We said this was going to be that value. Then we want to update this stuff. Time. Okay. So we shouldn't see any noticeable change, but we can again play with these a bit. So for the radius value, we could actually make this to be this, and then we adjust the radius. So maybe this is like maybe we add like the time value as it is assigned. And now okay, clearly the radius has gone, it's become huge. Let's say we add like 0.1 to it. Okay, yeah. Size is clearly being modified. Yeah, I'm thinking maybe like at the end of the game, once the puzzle is solved, the all of the polka dots like shrink to 0 or something. So by having it in the shader here, we'll be able to control it. So we'll say like to do make the radius go to 0 when the puzzle is solved. Okay. Yeah, but otherwise, wait, let's make sure it's still. I feel like we've built this heaps of time, and the cache may be really large. How large is the Z cache here? 1/4 GB. Okay, let's destroy that and build it again. And then, yeah, and then we'll call it a day. Okay, so now we've got the background from last time in the game. Finally, we want to adjust the period of this. So let's maybe I specified this in the shader itself. Yeah, currently it's changing every 1 second. So I think it would be more fun if it changes every like we want it to be like people will solve the game somewhat quickly, but maybe not super quickly. Maybe like 100, maybe 100 seconds is enough. Yeah, it's like, well, let's see, is it obviously changing? Because I think we want to make it slow enough that it's like it's not like change, you can't see it change if you look at it for a while. it's only over quite an extended period of time will you see it change. We also want it to be a circle at the beginning. It didn't seem as, yeah, it's not exactly a circle at the beginning. Why is that? Why is the shader location, why is it not 0 to begin with? Oh, because it's going to be at 0.5. So if we want to make this 2, then at the beginning, because then that's a circle. So wait, it's going to be 1.5 at the beginning, right? Yeah, the periodic value will basically be 0 at the beginning. So we want to shift this. So in particular, we want to yeah, we want to shift. Anyway, we'll figure this out next time. Yeah, given that it's building, let's save this and then we'll figure this out next time. Yeah, got background basically. Okay. So yeah, thanks everyone who dropped by the stream. And yeah, as always, if you wanted to just look and see the code that I wrote today, if you go into the sliding puzzle on my GitHub, everything's public. I still need to add a README and stuff, but you can see the again, like the shaders that I was just editing and compiled the program, etc. So yeah, see everyone next time. Bye.